let's do something kind of cool. We are now going to use the concept of rank 1 updates to define some really, really powerful matrices. So the first one we're going to define is called a shear matrix. So let's let n be an element of the natural numbers. For I not equal to k with I comma k element of the set of natural numbers from 1 to n, the n by n shear matrix S sub ik of c is equal to in plus c ei ek transpose. Can you use that notation to talk about this matrix? What would you call the shear matrix Sik of C? It is a rank 1 update of the identity matrix. Should we form some of these? Say yes. So let's look at example 3.4.4, and let's let n equal to 3. So in this case, we say, let's consider, we'll do a few of these actually, S31 of -5. So just a quick, what is I here? What's I? 3. What's K? What's N? Yeah, N is 3. What is C? Okay. Some of my students are not used to making specific connections between the notation and the definition and the way that we write it out. And so let me do this. What is the formal definition if I write Sik of C? What is that? It's I sub n plus C times ei ek transpose. Now let's just go ahead and write out those with these parameters. So what is this? I3 plus -5 times E3 E1 transpose. That's a lot. We just did a lot of work. We identified the parameters, we identified the definitions, we substituted the definitions back in. Don't do more math than that in one step. And make sure to actually write that stuff down. Okay, what's next? What is I3? Use some terminology from the class. It's a diagonal matrix whose main diagonal elements are all 1. And the strictly, now keep going, strictly, are all 0, which is encapsulated in the definition of main diagonal, right? Okay. Or diagonal, sorry. So now we've got plus -5 times, what is E3? Okay. 1, 0, 0. Okay, let's go ahead and look at this. This is a 3 by 1. This is a 1 by 3. What's the product? What size is the product? 3 by 3. Am I allowed to add 3 by 3 to 3 by 3? Okay, so I haven't broken any rules yet, right? What are you noticing about my level of consciousness in each line? Am I doing it blindly or am I doing it with my brain on? Always, always, always. And that's trained response, right? Let's go ahead and keep going. So now I've got 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a 3 by 3. Then I've got -5 out of, okay, what's this? What type of operation is this right there? How do I have known it's an outer product? It's not about the transpose. The transpose gives you the dimensions, but not vice versa, right? Yeah, so I agree with you. Just be careful though, right? Because I could define a row vector here, and if I took the transpose, it would be a column vector, in which case this would be an inner product, right? Yeah, so I agree with you that because this is an elementary basis vector, we think about those as columns, thus the transpose is a row. But formally speaking, the way that I identify this as an outer product has nothing to do with transpose. How do I do that? Yeah, look at the inner dimensions, and they should both be equal to 1, which goes into the theme. Every time we're writing matrix operations, specifically write the dimensions until your hands are bleeding, and then do it 10,000 more times, right? Okay, so what's this? 0, 0, 1. Yeah, now this is the most beautiful matrix ever to exist. You see that's a rank 1 update? How many linearly independent columns does that matrix have? 1. Rank 1, right? Because 0 is always linearly dependent, right? Because I can always write this matrix as 0 times that matrix. So there's a non-zero linear combination that gets to that, or excuse me, this vector is a linear combination of that vector, right? Okay, now what? What happens when I do scalar vector multiplication? Scalar matrix multiplication, sorry. Not everybody at once, please. What happens when I do scalar matrix multiplication? Everything gets scaled. What is 5 times 0? It's Wednesday, so that must be 0. 5 times 1 with a negative. What happens when I add those two things? So check this out. Some of my students are really quick on the draw, and they say, hey, Jeff, I could have done this with no work. 3, 1 gets value -5. Everything else has
0.
yeah, except for the she's like, I didn't finish my sentence. Main diagonal is all values 1. How would you have known the main diagonal is all values 1? Because I sub n is the thing that you're doing a rank 1 update to. So let's go ahead and make a conjecture. Let's do something crazy, shall we? Let's do n equal 5, and let's do s 3, 4. You have a favorite number, Chris?
7.
7. Without doing any work, and don't you dare do this to yourself. It's called trying to cut corners in an education. Don't do it. Could you guess what this is? Well, what is it? 5 by 5, so 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay, which 5 by 5 matrix is it? Yeah, watch this. Entry 3, 4 of S 3, 4 of 7 equals what? 7. 3, 4. Why do I say don't skip that step? Yeah, is the point of this to get the answers or the point of this to learn? Yeah, right? So what is, formally speaking, what is S 3, 4 of 7? Well, this is supposed to be SIK of C. What's the formal definition of SIK of C? I sub n plus EI EK transpose. Let's go ahead and just be explicit. What is I? 3. What's K? 4. What's N? What's C? So now I've got I 5 plus 7 E 3 E 4 transpose. How do I know what dot that is? Oh, she's like, I just want you to be quiet. Anna, you're so kind to me, though. Yeah. Yeah, it's important. The reason I do this is because many of my students think I'm joking. They're like, oh yeah, he's not serious. I'm serious. Write down the dimensions. Train yourself to do it. If you have any prayer that you want to use this in the future, get in the habit of doing that. Because eventually you won't have to write them down anymore because you check them. It's a nice thing to do. It's a useful memory habit. All right, what about this one? 0, 0, 1, 0, 0 times what? 1, 0. Maybe we'll go boom. Should I split the red C's? And I'll do like a really active. I probably shouldn't have done that because now you all are on camera. Smile, you're on camera. All right, let's keep going. So this implies that S 3, 4 of 7 is what? Here's a little game I used to play with myself when I got lazy. Anybody recognizing that you don't want to write them all out? Feel that? I would literally pretend like, oh, let's pretend that I had $1 for every one that I wrote. Because I had this feeling that if I got in the habit of writing this stuff, not only would, there's a certain, you remember I said like sometimes pain can be really useful to remember stuff? There's something that, in my mind, there's something that happens when I write stuff down like this. It forces me to slow way down, and I take the intellectual load that I'm holding much, much more seriously. I don't even know, there's probably some neuroscience behind that. Okay, so what's the next one? So all of them are 0 except what location? Yeah, because I take the third row and I multiply the third row by the row vector 0, 0, 0, 1, 0, right? So this third row is 0, 0, and then all of them are 0. And what does that mean about the placement of the 7? So now I've got this 1, 0, 0, 0, 0, 0, 1, 0, 0, 0. Plus, could be worse, could be raining. 7, 0, 0, 0, 0, 0, 0, 0. Now what? This is a 5 by 5, this is a 5 by 5. So, got a 1 right there. 7, 1, 0, 0, 0, 0, 0, 1. Done.